Hi everyone, welcome to the Discontinuities notes. So what we're going to talk about in this video is the different types of discontinuities in rational functions. So we have wholes, vertical asymptotes, horizontal asymptotes, and eventually we may talk about slant asymptotes. So first thing we have is a whole. A whole occurs whenever you cancel a factor from the top and the bottom out. So our steps for these is, first one, we have to factor everything and see if anything cancels. Okay, so let's go ahead and do that with this function that we have below. So we're going to start by factoring the top and the bottom. So I am going to take the top part right here and I am going to factor it. So I have 2x squared minus 2x minus 12. I notice that there's a greatest common factor of 2, so I factor that out, which leaves me with 2 times x squared minus 2x minus just x, because we factored out the 2, minus 6. Then I notice the inside can keep being factored. I notice there is not a number in front of the x squared, which allows me just to put negative 6 on top and negative 1 on bottom. So I figure out what can I multiply to get negative 6, add to get negative 1. That would be a negative 3 and a positive 2. So this factors out to be 2 times x minus 3 times x plus 2. So I'm going to rewrite my rational expression as 2 times x plus 3 times, it's x minus 3, there we go, times x plus 2, all divided by x plus 2. So on top and bottom, we see that they have a common factor. They both have x plus 2's in common. When those cancel out, that right there is when a whole happens. So to find the x value of the whole, we are going to set that factored we cancel out equal to 0. So x value of whole. We take x plus 2, we set it equal to 0. So we get minus 2 minus 2, which is x equals negative 2. So the x value of our whole is at negative 2. Now, to find the y value, we are going to plug in that x coordinate into the simplified function after we canceled, and that gives us the y value. Okay, so the y value comes from us plugging it in. So we got y equals, the simplified version is now 2 times x minus 3. So we're going to plug in negative 2, which gives me y equals 2 times negative 2 minus 3, which is y equals 2 times negative 5. And that would give me a y value of negative 10. So we have a y value of negative 10 for our whole. So now we can state that there is a whole at negative 2, negative 10. Moving on, we have a vertical asymptote, or VA for short. Okay, so a vertical asymptote occurs at the values that make the rational expression undefined, which means we set the denominator equal to 0. So the denominator is the bottom part of the fraction. Looking at my equation, I have y equals 3 divided by x minus 3. So I'm going to take my denominator and set it equal to 0 for my vertical asymptote. So I have x minus 3 equals 0. I add 3 to both sides. I get x is equal to 3. So there is a vertical asymptote at x equals 3. A vertical asymptote is not the same thing as a whole. So a vertical asymptote would represent the infinite discontinuity, where a whole is the removable discontinuity. Now, something super duper important, okay? A rational function cannot have a whole and a vertical asymptote at the same spot. So we have to make sure we always check for wholes first, and then we check for vertical asymptotes. So if something cancels out, then it is a whole. It cannot be a vertical asymptote. So we have an example here. We're going to start by factoring the top and the bottom because that is our first step. So looking at my top, I have x squared minus 5x minus 6. There is no greatest common factor. There's not a number in front of my x squared. So I can go ahead and factor with my x. I put negative 6 on top, minus 5 on bottom. I think about what I can multiply to get negative 6, add to get negative 5. That would be a negative 6 and a positive 1. So I have x minus 6 and x plus 1. I'm going to go ahead and rewrite my numerator. So I have x minus 6 times x plus 1. Now I factor my denominator. My denominator is x squared minus 1. This is known as a difference of squares. So on this difference of squares, we can start with our two sets of parentheses. We take the square root of x squared, which is x times x. We take the square root of 1, which is 1 and 1. And I have 1 plus, 1 minus. So I have x plus 1 times x minus 1. So what we need to check for is there anything on top and bottom that cancel out? Well, yes, there's an x minus 1. An x plus 1 on top and an x plus 1 on bottom. So that means we have a whole. The whole is at the value when we set x plus 1 equal to 0. So that means we subtract 1 from both sides. We get x equals negative 1. Now, to find the y value of the whole, okay, we are going to take that reduced fraction of x minus 6 and over x minus 1, and we are going to plug in negative 1 for each x. So I get y equals negative 1 minus 6 over negative 1 minus 1, which is equal to negative 7 over negative 2, which gives me a y value of positive 7/2. So I have a whole at negative 1 7/2. Next thing I need to do is check for a vertical asymptote. So I would take the reduced part, or the part of the denominator that did not cancel out, which would be this x plus or x minus 1, and I would set that equal to 0 and solve. So my vertical asymptote would be when that x minus 1 equals 0, and I solve for 1 by adding 1 to both sides, and I have a vertical asymptote at x equals 1. So notice how my vertical asymptote and my whole are not at the same spot. And my pen is not working right today. I don't know what's going on with it. There we go. So that is wholes and vertical asymptotes. Wholes occur when the top and the bottom have something that cancel out. The vertical asymptotes, anything left in the denominator, the bottom part of the fraction, we set it equal to 0, and that is our vertical asymptote. Again, they cannot have a whole and a vertical asymptote at the same spot. Now, we have horizontal asymptotes. These are found by comparing the degree of the numerator to the degree of the denominator. So, I made this little chart for us, and it tells us when the top is less than the bottom. Okay, so if we need to make note, top is less than the bottom, we have a horizontal asymptote of y equals 0. So how I like to remember this is I say BOBO. BOBO means bigger on bottom. There's a 0 asymptote, y equals 0. Then we have when the top is greater than the bottom, we have no asymptote. So I say bottom. Bigger on top, no asymptote, or none. And then we have top equals bottom, so that's when the degree of the top equals the degree of the bottom. And then we just divide those leading coefficients. What I like to say to remember this is eats DC. Exponents are the same, divide their coefficients. So let's look at our 3 examples that we have here. Y equals x divided by x squared minus x minus 2. So I notice that on top I have a degree of 1. On bottom the highest degree is 2. The bottom is bigger than the top, so we say bigger on bottom, which is BOBO. And bigger on bottom tells me that my asymptote is y equals 0. And that's it. I look at the next one. I see that the top has a degree of 3. The bottom has a degree of 1. This is bigger on top. Bigger on top means there's no asymptote, so there is no horizontal asymptote. Looking at our next one, the top has a degree of 2, that's the highest exponent, and the bottom has also a degree of 2. So we're going to take the leading coefficients and divide them. Well, the leading coefficient is the number in front of the variable with the highest exponent, so that would be -2, and the other one would be a +1. So I am going to take y equals, so this is an eats DC, before I get too far ahead of myself, eats DC. Exponents are the same, they're both 2, divide the coefficients. -2 divided by 1. -2 divided by 1, which is just y equals -2.